Hello students, welcome to LearnGuru Classes. So today we are going to discuss about the properties of irrational numbers. Last class we have studied what are irrational numbers as those numbers that cannot be expressed in the form of a ratio, that is p by q, are termed as irrational numbers. Next, how to identify those irrational numbers. Any non-terminating and non-repeating decimal expansions are termed as irrational numbers. Secondly, square root of some numbers or cube root of some numbers other than perfect squares and perfect cubes under square root and cube root respectively are also termed as irrational numbers or recognized as irrational numbers. Okay, next we have studied that what is pi, what type of number is a pi. Pi is nothing but an irrational number along with justifications we have seen. So today we are going to discuss about the properties of irrational number, like if you add two irrational numbers, what will be the outcome? If you add one rational number and an irrational number, what will be the outcome? So these things we are going to study today. So let's start the class. The first statement is negative of an irrational number is an irrational number. Okay, so I am going to explain you the statement, but I am not going to prove it. Okay, I am just going to explain you with some logic. Okay, so the negative of an irrational number is an irrational number. So what is given in the statement? Suppose, and let us take any irrational number. So let x be an irrational number. Be an irrational number. Okay, so x, we let x be an irrational number, let it be root 2. So we already know that root 2 is an irrational number because 2 is neither a perfect square or a perfect cube. Okay, so play any number that is placed under root, so that is an irrational number. So negative of root 2 will be what? Negative of root 2 is minus root 2. Okay, so minus root 2 will also be an irrational number. So therefore, what? Minus root 2 is an irrational number. Why is it so? Why is it so? See, root 2, if you find out the decimal expansion of root 2 is 1.4142135, something like that. So this is a non-terminating and non-repeating decimal expansion. So minus root 2 will be what? You will just replace the same, means you will just add a negative sign with that. 1.4142135, something like this. So now minus root 2 also appear as a non-terminating and non-repeating decimal expansion to you, which is also a property of an irrational number, which is also an irrational number type of, we identify this as an irrational number. So we can say that minus root 2 is also an irrational number, that is negative of any irrational number is always an irrational number. Okay, but some of you may make small mistakes like that, small minute mistake that will create a huge problem. Okay, suppose if it is our negative of an irrational number, probably you will be writing root over minus 2. So that is completely wrong. That will not be identified as an irrational number. That will be a complex number. So it is very much necessary that it is for you to understand the difference between root over minus 2 and minus root 2. Okay, so these mistakes are the common mistakes that students make. So you should avoid these mistakes. Okay, root over minus 2 is a separate entity called as complex number, whereas this minus root over 2 is the negative of the irrational number root 2, which is asked in the statement. So don't get confused with these two notations. Okay, so let's move on to the next statement. The second statement is the sum of a rational number and an irrational number is always an irrational number. Okay, so let's find, let x be a rational number. Let x be a rational number and let us take x is equal to 3. So 3 is a rational number, right? 3 can be expressed in the form of p by q. So 3 is a rational number. Now y be an irrational number. Irrational number. So y is taken as y equal to root 2. So root 2 is also is an irrational number. Okay. So now what you have to do, if you add these two numbers, that is rational number and an irrational number, the result that you will get, so that should be an irrational number. That is z equal to x plus y. Okay, so 3 plus root 2 is an irrational number. Okay, is an irrational number. Now why is it so? Why is it so? You have to establish this statement. We need to understand this statement with logic, isn't it? So what is the decimal expansion of root 2? Precisely 1.414213, something like that. So this is an irrational number. So let us add 3 with this. So plus of 3. So after the decimal point, place as many zeros as that of root 2, that is 1.414213. So what will you get? 414213, something like that. So what type of expression is this? So this is a non-terminating, non-repeating decimal expansion. That is the result that you are getting by adding an irrational number with a rational number. The result is also an irrational number. From this only you can see, isn't it? So the statement that is always, if it is asked in the objective type of question, MCQs, that sum of a rational number and an irrational number is always an irrational number, and we have tried to understand this with this logic. Okay, so let's move on to the third statement. The third statement is the difference of a rational number and an irrational number is an irrational number. So this is just like the previous statement. So x be a rational number. Let x be a rational number. Rational number. So x is, let x be 3. Okay. So y be an irrational number. Irrational number. So that let it be root over 3. Okay. So the difference of a rational number and an irrational number, that is you are to subtract a rational number from an irrational number. So that is z will be x minus y, that is 3 minus root 3 is an irrational number. Okay, why is it so? Again, same logic. 3.000000, root 3, the decimal expansion of root 3 is 1.732, something like this. So ultimately the result that you will get as z, that will also be a non-terminating and non-repeating decimal expansion. So whenever you subtract a rational number from any irrational number, so the result will also be an irrational number. Okay, so let's see the fourth statement. The fourth statement is the sum, difference, product and quotient of two irrational numbers need not be an irrational number. So what is it? That if we, in some cases, not in all cases, in some cases if we add two irrational numbers, the result may be a rational number. If we subtract two irrational numbers, the result be a rational number. If we divide two irrational numbers, the result may be a rational number. Similarly, if we multiply two irrational numbers, the result may be a rational number. So first, let us see how sum of two irrational numbers may not be an irrational number. So let us take one example for sum. I am giving here sum of root 2, suppose x equal to root 2 and y equal to minus root 2 is what? Root 2 is an irrational number. Minus root 2 is also an irrational number because negative of any irrational number is also an irrational number. So z equal to x plus y, that is root 2 plus minus of root 2, that is root 2 plus minus root 2, so that is 0. So what type of number is 0? 0 is a whole number, and whole number means it is a rational number. So we can say that in this case when an irrational number is there and a negative of an irrational number is there, so that time of the same irrational number is there, the sum or the result will be a rational number. Again I will say, if one rational number is there and the negative of the same irrational number is there, so the result will always be a rational number. But if we add, suppose if we give x equal to root 2 and y equal to root 3, both of these two are irrational numbers. But here if we do x plus y, that is root 2 plus root 3, so that will be an irrational number. Why is it so? Because root 2 1.414213, non-terminating decimal 1.732, something like this. So the result that you will get, that will also be a non-terminating, non-repeating decimal. So that is an irrational number. So this is the case when the sum of two irrational numbers may not always be an irrational number. Exception is this. Okay, now let's move on to the next statement. Next, the difference. Let's see how difference works. So difference of two irrational numbers need not be an irrational number. Why? Let's take an example. X equal to suppose root 3 and y equal to root 3. So z will be what? X minus y, the difference. So root 3 minus root 3 is 0. So 0 is an irrational number, right? 0 is a rational number, right? So from that what can you conclude? To the difference of two irrational numbers of same two irrational numbers, root 3 and root 3 are same irrational numbers, isn't it? So the difference of two same irrational numbers is always a rational number, that is 0. Okay, but if we take another example like x equal to root 3, y equal to root 2, so z equal to x minus y, that is root 3 minus root 2, so that will be an what type of number will it be? Rational or irrational? Yes, obviously it will be an irrational number because root 3 1.732, something like that, root 2 1.414, something like that. So the difference will also be an example of a non-terminating, non-repeating decimal expansion, which is an irrational number. So what do we say? The difference of some irrational numbers, like two same irrational numbers, difference of two same irrational numbers are always 0, that is a rational number, but exceptions are something like that. Okay, not exceptions. This is the common way. This is the exception. Z equal to of two same irrational numbers is always is a rational number. Okay, so let's see how the product and the division of two irrational number works. The product of two irrational numbers may not be an irrational number. So let's see how. Suppose you are given example, that is root 18, x equal to root 18 and y equal to root over 2. Okay, so z will be x into y, that is root 18 into root 2. Okay, so you have to see whether the product is a rational number or an irrational number. So before that, 18, if we rationalize it, 2 9s are, factorize it, 2 9s are 18, 3 3s are 3. So you can write this as 2 into 3 into 3 and into root 2. So that is we can write root 2 into 3 square into root 2. Okay, so 3 square, so 3 will be out of the root. Why? Because the power of root is half. So 2 into half gets cancelled. So you will be 3 into root 2 into root 2. So root 2 into root 2, that is 3 into, you can just replace it with 2 to the power of half, and this is 2 to the power of half. So 3 into 2, half plus half, that is 1. So 3 into 2 is 6. So what type of number is 6? 6 is obviously a rational number. So in this type of examples, product of two irrational numbers may not be an irrational number. But if we multiply, suppose x equal to root over 2 and y equal to root over 3, so z is what? Root over 2 into root over 3. So that is root over 6. So root over 6 is an example of an irrational number. Okay, so let's see how the division of two irrational numbers work. So for that, let us take x equal to root over 12 and y equal to root over 3. Okay, so z will be x by y, isn't it? So x is root over 12, y is root over 3. So 12 by 3, 3 4s are 12. So root over 4. So root over 4 is 2 square. That is 2. So 2 is what? 2 is a irrational number. So this type of examples of two irrational numbers give a rational number. But on the other case, if we just substitute or change the value of root 3 to root 2, what will be the outcome? Z equal to x by y, that is root over 12 by root over 2. So that is root over 12 by 2. So you are getting it as root over 6. So root over 6, neither it is a perfect square or it is a perfect cube, because it is a square root, not a cube root. So root over 6 is an example of an irrational number. Okay, so from this what you have concluded, what we have come to the conclusion that the mathematical operations of two irrational numbers in some cases may not always bring you the result, may not bring you the irrational number. It can be a rational number for some of two irrational numbers, like one irrational number and negative of the same irrational number will give you the sum as 0. For difference, what you will get? The difference of two same irrational numbers will give you a rational number, that is 0. And for this product, this type of sums where you have similar type of roots, suppose root 2 into root 2 or root 3 into root 3, will also give you a perfect square, that is a root will be removed and ultimately you will get a rational number, and similarly for the division, if you get a perfect square as the quotient, so that will also be a rational number. Okay, so I think these properties are clear to you. Okay, again it will be more clear when we will be solve sums based on irrational number. So next class we will solve some numericals based on irrational numbers. So I am ending the class here. If you find this video helpful, please subscribe to LearnGuru Classes, like, comment and share it with your friends and relatives. So thank you very much. Bye bye.